This lesson covers monitoring and alerting as concepts. It then illustrates the application of these concepts with the Stackdriver service, including the kinds of monitoring that can be configured, how to set up an alert and notification, and how to create a dashboard with charts to help visualize the running system.
Here's the SRE pyramid, which is a hierarchy of critical processes for implementing SRE. You can read more about it in Google's book, Site Reliability Engineering. When you take a look at the SRE pyramid, eventually everything really starts with monitoring. Once you've activated a monitor and defined alerts, you have to respond to the incident and complete your postmortem. What was the result of the root cause analysis? Repeat and recreate testing release and procedures. Perhaps you need to change capacity planning, redeploy, and/or update the product. So in this case, monitoring reveals what needs urgent attention. It helps you identify what trends exist, which will help with forecasting and planning. It will also help in identifying any potential improvements. What's also key is black box and white box monitoring. In this case, white box monitoring is going to identify the actual services themselves. Black box monitoring doesn't assume there's anything in the back end. It kind of represents the customer-facing point of view. So you want to certainly focus on the different options there when it comes to monitoring. Now, there's really only two types of metrics. You can have push-based metrics, which will simply send out alerts. For example, a disk is full, or you have a new item that's been uploaded to a bucket. That way, you're going to send out a webhook notification. Or you can pull from the outside. So you're periodically doing a push-pull, trying to check at certain intervals to make sure everything is functioning. If you don't have the ability to tell yourself that something is down, you can also verify if the service is down by periodically monitoring to see if the service responds. When you apply this to your user experience, this is where the black box monitoring takes place. This measures what the user experiences. It doesn't realize that there's a whole chain of business logic and microservices that you've segregated into clusters, that you've distributed storage with private networks, and so on. It doesn't care about any of that. But user experience is what you should care about most. If this is affected, then you will go to your white box monitoring to identify where in your business logic it's breaking down and possibly affecting that user experience. So white box monitoring, in this case, is going to monitor the individual services, and you'll apply those accordingly. So in this way, when you're asking the 5 questions and identifying where the potential problems are, you'll look at your white box monitoring service level indicators to determine which part of the business logic could be failing that's affecting that user experience. Monitoring systems shouldn't rely on humans to determine if a particular condition warrants a response. Rather, we should program them with the intelligence to determine if a condition falls within a predefined or even dynamically defined threshold. Using this information, the system could determine the severity of the situation based on our guidelines. This helps prevent the all too common scenario where we as humans tend to ignore alerts because we make assumptions about the severity of the situation. If instead we had a system to triage the alerts and errors, we could react more appropriately to the alerts we receive. For instance, an alert should only be sent to a human if an action must be taken immediately. Depending on the level of availability designed into your workload, this might even exclude individual server faults because the system would be designed to automatically work around those faults. Instead, this type of notification should be reserved for situations when the availability of the service is in significant jeopardy unless a human becomes involved immediately. An example of this could be multiple failures in the subsystem that was designed to tolerate only a single failure. For issues that won't immediately affect the user experience, the monitoring system should create a support ticket instead of generating an alert. Support tickets are handled during normal business hours and are not intended to wake the on-call person. By redirecting these alerts to tickets, the humans become more accustomed to reacting quicker to actual alerts. Tickets should be used for the failure of redundant systems that don't represent an immediate threat to the user experience. The monitoring system should send all other events to a logging repository, such as Stackdriver, so that we can report on the information or use it during diagnostics and also while troubleshooting. So, how do you design for the 12-factor administration and operations in GCP? Well, something that is designed to treat logs and events as streams. Now, you've kind of created your own in your own log measurement, but you could most likely replace all of this with Stackdriver logging. Because Stackdriver logging can ingest this in real time, it makes it queryable. It can also export in real time to BigQuery and or Google Cloud Storage for long-term archive. So there's a lot of flexibility there, and maybe this is how you want to do post-processing. In this case, you also want to run administration and management tasks as a one-off process. This way, you don't give the humans full root access. Perhaps you have them authenticate and utilize service accounts to do major functions. These can be auditable, and you can easily revoke access. Stackdriver can handle everything end-to-end, from the monitoring, error reporting, cloud tracing, and debugging. But these last three features are exclusive to Google App Engine and are only possible if you're using that service. So, when you take a look at Stackdriver, it's actually a collection of tools that are unified together. So from a monitoring standpoint, it replaces things like Nagios or WhatsUp Gold. Internally, Google uses FluentD to capture logs, which can actually be captured from any location in the world, even if it's not a Google service. So you'll see Google FluentD is capable of ingesting log data. Error reporting, trace, and debugger are all available in App Engine, and there's a number of different third-party programs as well. These are all integrated into the Stackdriver service, and what's great is that an auto service discovery functionality identifies any Google Cloud service that you're using. Now remember that Stackdriver uses eventual consistency when it comes to initial deployment. So if you've spun up a cluster of VMs, it might take a few minutes before Stackdriver sees an instance and turns on monitoring. Stackdriver is unique because it was a third-party acquisition that was originally built for AWS. You actually have AWS as connectors, so you can monitor various products in AWS as well as multiple products within GCP. When setting up Stackdriver, it's recommended that you create a separate Stackdriver account all by itself and that you have a separate authentication mechanism. It shouldn't be tied to the CEO or the CIO or some special individual. This is a separate account that needs access to monitor everything. So this way, you can create an isolated security mechanism and its own account to monitor utilizing these various services. So let's go through some of the features. One is an uptime health check. You want to make sure that you're monitoring your uptime. This is how you check for your error allocation for the month and trigger any alerts if anything goes down. So by default, you can make very nice graphical visualizations which consist of and can actually show you your service level indicators for the month, and any outages can be tracked. So it's very easy to start to report on uptime and also create simulated walkthroughs. In this case, you're just going to simply hit the home page and identify if it's up or down, and then count it as a timeout if it times out after 10 seconds. So at some point, you will have a failure that has occurred. Basically, your alerting policy will define what the health condition is. You can have multiple conditions and different kinds of notifications. Do you want to send out an email alert or a Slack channel alert? Do you want to do a webhook notification? Perhaps you know that there's a memory allocation issue and the process is just to reboot the server. So you don't need a human for that at all. You can send out a webhook notification to an application that's listening for that webhook, and then it can run as a service account to restart the VM, or something simple like that. Then there's documentation, which is key. Those involved need to have a clear understanding of what the problem is, as well as what needs to be done to fix it. Think of those on call who might not have the required levels of experience or expertise to solve the problem. This information can be extremely helpful to them. It's also an opportunity to document best practices. So the other cool thing about Stackdriver is dashboards and graphs. This gives you some great visualizations. It gives you historical information and helps you find correlations. You can scroll through and create groups of services, or scroll through a specific time and identify events, such as a spike in CPU, which is associated with memory allocation, and so on. So these visualizations can help you compare and test with early warning results and production results, so you can see what's going on inside of production. What's great with the Stackdriver dashboard and charts is that they're dynamic. So in this case, if you were to drag the horizontal line on the chart that reflects CPU utilization, the line that reflects bandwidth will move accordingly. This allows you to see visually what the impact of changes will be without taking risky guesstimates. Installing Stackdriver is very easy. There are some basic built-in monitoring functionalities out of the box inside of the VM. But if you want all of the additional capabilities, make this part of a startup script. Through this script, you can install the Stackdriver agent as well as the logging agent. With the log details, you can capture not just the system logs, but a number of custom applications. So Cassandra, MySQL, Postgres, Java, different runtimes, custom metrics, all sorts of things. So you definitely want to install the agents, even Apache and Nginx. There's a huge list of integrations with the logging agent that we can capture.